Alright, in this lesson we'll just modify what we did in the previous lesson by changing the axis of rotation. So in the previous lesson we rotated all the regions around the x-axis, and if we had this small rectangle and we rotated it, it would reflect down here and we would have a washer and if we rotate infinite number of rectangles around, then we'll get the solid, and here it'll be kind of like some type of cone. When we calculated when we found the integral, we had to find the intersections, and we also have to find the two radii. The greatest distance from the axis to the end of the region, and then from the axis to the closest part of the region, big R and little r. And we're going to do the same thing here, except now we could rotate the region around a line other than the x-axis. We have the small rectangle reflected, and we would have this washer. Same thing as we saw above. And here we're just going to look at the big R is going to go from the axis to the furthest part of the region, just like it did up here. Axis to the furthest part of the region, axis to the furthest part of the region, axis to the closest part of the region. We find each of these lengths still by doing top minus bottom, but now the top will be the axis and the bottom will be the function. If we have an axis below the region, it'll still be top minus bottom. Find the volume of the solid formed by revolving the region bounded by x squared plus 2, x equals -1, x equals 1, about the line y equals -1. So let's look at the region, x squared plus 2, and also the vertical lines at -1 and 1. And I would also have to say that it's bounded by the x-axis. It's rotating around -1, y equals -1. So we have to think of, should we use vertical rectangles? So does every rectangle that we draw have the same top and bottom? Yes, so let's use vertical rectangles, and that means we need to have the integral in terms of x. If we have the integral in terms of x, we need an x interval. We can see the intervals from -1 to 1. Alright, let's find the radii. So we would start from the axis and go to the furthest part of the region, and that will be capital R. Capital R is top minus bottom. So top is x squared plus 2. The bottom is -1, top minus bottom. And little r is from the axis to the closest part of the region, and that's going to be top minus bottom. Let's find the area of a washer, and that's going to be the circle with a large radius, that's pi r squared, minus the circle with a small radius. So here that is pi r. This is r. It'll be x squared plus 3. Pi r squared minus pi r is just 1. The volume of a washer is going to be the area times dx. And then rate from -1 to 1, that's the x interval. And then we just copy this. If we did that with a calculator or Desmos, we should get that. Okay, rotating a region around an axis, a solid of revolution. Pause the video and try that one. So here's a parabola shifted to the right.